Hi everyone, in this lecture we are going to discuss a problem in which we are given a 2D array, and this 2D array is sorted along the rows and it is also sorted along the columns, and what we want is we want to search for an element that is given. Okay, so basically we want to do some kind of searching on this 2D matrix. So let's see this example. Now we have this 2D matrix, and let's say someone says maybe you want to search for an element 33, or maybe you want to search for an element 29. So how you are going to do it? So we are going to discuss multiple approaches. The first approach is a brute force approach, in which we can simply iterate over the entire array, row by row or column by column, and we can say, okay, this is where this particular element is present. Okay, so that is going to take n into m time. So we are going to traverse the entire matrix. So this is nothing but a linear search on a 2D array. Okay, and this would be a brute force technique. Second would be, can you do something of this sorted property? We are not using this information, the array is sorted. So can we think of something using sorting? So let's see. We have learned that we can use binary search on sorted arrays. Okay, so what we can do is we can say, okay, why not do binary search on each row? So on each row, what we can do, we can say, okay, we can do a binary search. Okay, so maybe we do binary search here, that is going to take log of m time, and we have n number of rows. We can do binary search on all the rows, and in the worst case it is going to take order of n into log of m time. Okay, because binary search takes logarithmic time complexity. So this is another way, but can we still do something better? There is still some information that is present in this question and we are not using it. Okay, so this binary search would still work if the array was not column wise sorted. Okay, because we are not using this information, the array is also sorted across the columns. Okay, so in every problem you have to carefully analyze what information is given and how you can exploit it. In the first method we did not use this information, the array is sorted, but when we used the array sorted, we came up with a binary search idea. But in this binary search idea, we're just assuming that the rows are sorted and the columns are also sorted. So can we think of something using which we can still reduce the complexity of the search? Okay, so maybe what we can do, maybe I will say, let me start with this element 10 and I want to find an element 33. So in which direction should I go? The answer is not very clear, because if you go right, okay, so you want to move towards a bigger element, that is 33 from 10. So if you go right, the data is increasing. If you go down, the data is increasing. So it is very confusing. We cannot start from this point. Okay, but if you look at this point or this corner, one of these, any one of these you can pick. If you look at this point and you know we are at 40 and we want to look for an element that is 33, that means 33 is going to be smaller than 40. Okay, so what we can do is we can move in a direction. So if from this, if you move left, the data is going to decrease. If you move down, the data is going to increase. So in which direction should we move? We should move left, because we want to find an element 33. Now we are at 30 and we want to find an element 33. So if you go one step left, the data is going to decrease, so you will go one step down. Okay, so at 35 you will see where should I go now? You should go left, because 33 is smaller than 35, so you go here. At 25 you want to go to 33, so you should go down, so you come here. At 29 you again want to increase your value, so you will go down and you will end up at 33. So this was the key element, and now we are able to figure it out in just a traversal like this. Okay, so what is the worst case for this? So we can say, in the worst case we are traversing one row and one column. Okay, so that means from a quadratic complexity we have reduced our complexity to linear. So we can solve this problem in order of n time, and since this forms a kind of a staircase path, this algorithm is also known as staircase search. Okay, so I hope this idea of staircase search is clear, and what I want is you try to implement this idea in your code, and in the next lecture I will show you the solution.